guys, today we will focus on our CS2316 project crime analysis. I'm Tong Hui.
Hi, this is Han.
This is our content. Let's enter the first part purpose. Why we chose this topic, these are our reasons. Big cities are not only the embodiment of human highly flourishing culture, but also the breeding ground of evil behind the bright lights. There are a lot of crime incidents in big cities, which are much higher in other areas. Therefore, there is a great desire for us to better understand and predict criminal incidents to prevent and avoid the harm caused by criminal incidents. We try to solve this problem through data analysis. We have two goals: find better prevention, identify the factors of crime, and create a safer city. Let's enter the second part: data collection and data cleaning. We have total 6 data sources: crime data in Phoenix, crime data in Arizona State, crime data in Washington State. We found the dataset in City of Phoenix Open Data for the first dataset, and the second dataset in the crime reports is derived from the annual Uniform Crime Reports issued by the FBI until 2020. We searched the government website and found it in the government website in Washington State. There are also 3 additional datasets: crime data in Atlanta, crime data in Chicago, and crime data in New York State. We searched the Data World website and found this dataset. We found the crime data in Atlanta in this website. We also searched the Chicago website and found it in Chicago Data Portal. The third dataset, crime data in New York State, is found from the data website of the government.
So for the first download data set here is actually the crime data in Phoenix. We found that there's many inconsistency in this case. For example, there's for the column RQ2 and those two actually have a really disgusting format as we want. We'll convert that to date time. For the column, those two column also that has a bunch of does not have a bunch of missing values in this case. So we add the medium there. For the prime time, we just add the frequent one to the non-space there. And we also convert to a time interval in such a case in order to help us more easier to analyze. And later we drop the column since we don't need to use them. For the zip code, it's actually in the string type, and we convert that into the integer type. And later, because we drop a bunch of colon and rows here, so we reset the index to make it clear to when we slicing this data set, and then we convert that into the CSV file. For the second one, it's actually in the it's the dataset in the Arizona state. It's HTML web page file. While we convert that to the kind of data frame, we find that the table there are many tables there, and we just need a 5 and 8 one. And we figure out that the column name is not given to us, so we did a bunch of process to make sure we have the correct column name. And after that, we combine those two tables together and the column name and convert that to the kind of data frame. And then we convert to the CSV again.
This is our data cleaning of a web collection too. We transferred the JSON to a dictionary with .json and abstracted the data from the dictionary to the list using append. However, JSON does not directly give us column names, so we just use the append to add the columns titles one by one. Ultimately, we convert the list of lists to Panda data file. And after that, we convert the data to the CSV file. And this is our data cleaning of the additional data set 1. We firstly convert CSV to pandas. And those columns are not we don't need, so we just drop them. The first column is also distressed, and we don't know how to deal with it, so we just forget it. We also drop the non-values in the data set. We transfer the data type of the date from the string to date time. After conducting sorting and reset the index, we export it to the CSV files. This is the data cleaning of the additional data set 2. We firstly convert CSV to pandas, and we only need the columns below, we just abstract these columns from the dataset. There exists a few missing data, but not too much, so just drop them directly. After resetting the index and drop them, we transfer the data type of the zip code from string to integer, and transfer the data type of the date from string to date time. After that, we export it to CSV file. This is our data cleaning of the additional dataset 3. We firstly convert CSV to pandas. The number seems to be in a numeric format, but it is actually in string. For this case, we utilize slicing of data frame to select all the data and convert them to integer. Although the dataset has no value, we can assume there is not such case, which we use fillNone to fill no space with 0. And this is our third part: data analysis, insights, and variables.
So for the inside one, we're gonna analyze the crime type, time, and the location. So in this case, we compare the data sets in Phoenix City and Atlanta where we live, and we find that there's a bunch of mismatch on the on all those three stuff, and we match on the type and the time because they could be matched, but for the location we couldn't match things, so we have to cover that individually. So our insight three is the correlation between population and crime rates. So in this case, we compare the Arizona state and the Washington state, and we wanted to talk about how the relation between the population and the each crime cases in this case. And we figure out that the given after the process, we find that the correlation coefficient of all above is actually larger than the zero point 0.9, which means there's a strong positive relationship between the population and the crime cases. So this could be also indicate that if the population increase, that would cause the number of the crime increase as well. Our insight four is talking about the motivation of the crime. In this case, we can analyze on this data state of the on data sets of the New York. In this case, we figure out that specific motivation is not really satisfy us, and we also wanted to analyze if the general motivation also can give us some idea. So we actually group them together, and this is a table that we generalize as well. And later we draw another graph that can be assessed to the inside four. And we found that the anti-Jewish and anti-black and anti-gay male is actually actually the largest part that dominates this chart the most. And as you can see, the general motivation that we create is not really intact since the anti-Jewish dominates the most, and the rest doesn't really have the higher potential there. So in this case, we figure out that we probably we have to use a specific motivation to analyze in this case. Moreover, we feel like the society should be multicultural, so we should endure more stuff in our society, and we probably have to solve in the future as well. For the insights file, we're gonna conduct the crime prediction. In this case, we import a new molecule that's help us to do the linear regression in this case. So you can see we find the intercept and the coefficient that can help us to build the models there. And we also find that R squared is really close to one, which means the prediction value that we made is really close to the actual value. Moreover, we create a data to show the comparison between the actual value and the prediction, also to show how the prediction goes in the future. And you can see there's both of them shows a period trend, and there's a criminal case in the beginning of each year, and more criminal cases during the summer every year. So this is a match what we saw in the in the previous insights. And as you can see, both of them also shows a decreasing trend over the years. So which means our city, Atlanta, is becoming safer and safer.
This is our overall results and conclusions. We get pattern of crime type, time and location, pattern of death caused by crime, relationship between increasing population and crime rate, motivations of crime and crime prediction.
So those three modules are actually we didn't learn in the class. So the one on the left is actually help us to analyze the insight five which apply linear regression on the data. So this help us to generalize the predicting mode based on the given data. So the one on the right called PolyGo is actually help us to apply multiple for the visualization one is help us to apply multiple data in the same graph. And for the visualization too, we use that as well. So we can complain the PolyGo. We see other subplots there, so we can make a multiple graph in our pictures.
Thank you for listening.